This video was produced by
The expert of today we will need to demystify is Professor Chris Hughes. He is a professor in the Physics and Astronomy department and also the director of the Center of Material Science at JMuse.
Do you make baseball bats out of gold?
Are you an alchemist?
No.
How to turn plastic into gold.
Maybe the expert would tell us why he's doing what he's doing without telling us what he's doing.
Because people pay me to do it.
Also, he's doing some things that are useful.
It gets funded by the National Science Foundation, yes.
Are you combining other elements to make gold? And the other one that you named that I can't remember.
Plastic?
Is it plastic laced with gold?
Yes.
Oh.
What does that mean? And
So ironic.
Sports.
So you're making pretty plastic.
Yes.
Are you making? Are you trying to increase plastics usage in the world in some fashion?
And then short the market and then get rich and then go to some place?
Do you have room for investors?
No, yes, no.
Why is it made out of plastic and gold? Yeah.
Plastic is cheap and easy to manufacture and can be recycled. And gold
It's the opposite of that.
Yeah.
Yeah. And when you combine them together, and gold is a very good conductor and reflects infrared light really, really well, and is very inert. Doesn't react with a lot of things. Making chips that can carry fluid inside them, very, very small amounts of fluid. And in principle, that could be used for things like DNA sequencing or diagnosing disease, stuff like that, because you could take biological specimens and move them about on this piece of plastic through these little tiny pipes. The gold is there because one of the ways that you like to inspect that is by shining light on it, and if you put gold there, you can reflect the light off the gold and look inside these little tiny pipes. So
It's like
that-
a machine?
Inside of you? Like if
no,
in
it's
it?
external.
Okay.
So it'd be a thing about the size of a compact disc, if you remember what those are. And it
They were colorful.
and it has basically channels, pipes, if you will, inside it. They're roughly the size of a human hair. So they're extremely small, so the fluid flows differently inside them than it would in a sewer pipe, for instance. The problem, I mean, as I mentioned, we're trying to make these devices and we want gold to be in there to reflect light. But gold is extremely inert. That's why we use it for jewelry. It doesn't react with stuff very well. And plastics are also very inert. So you've got something that doesn't like to have stuff stuck to it and something that doesn't like to stick things, and we're trying to make them hold together. And we just kind of stumbled upon really an accidental discovery that if we just waft this thing through a chloroform vapor, that the chloroform gets into the polymer in a way that makes the gold stick to it. So we filed a patent on that. And,
How did you accidentally drop plastic and gold through a chloroform?
we just happen to have chloroform around the lab.
Whenever like scientists explain,
No, the plastic actually will dissolve in chloroform. So it's a common thing to dissolve the plastic into the chloroform. It is why a curveball curves.
Wow. Okay. So does that have something to do with the friction against the surface of the ball and the medium in which it travels?
Yes, so you got a ball spinning, and as the ball spins, right, what'll happen is the velocity of the surface of the ball with respect to the air around it is different on one side than the other, which leads to a push to the side on the ball. So if I throw a ball and it's spinning like this, it will curve off to the side.
Like an
An
airfoil?
aerofoil, yeah, actually, yes, yep. The arrow, what you talked about is what's called a rifling effect. If it's spinning like this, twisting as it goes, you don't get that effect. Okay, it's a side-to-side thing because the ball is spinning sideways as it's moving forward. So that's what the Magnus force is all about.
Can nanoscience be run on a nanobicycle?
No. No. The smaller the thing, the more expensive it is, right?
What about the space
What a
shuttle?
crazy world we live in.
Yeah.
Who's right now, Mr.
Yeah.
Scientist?
So why were blue LEDs so important that they got a Nobel Prize?
Have you ever really looked at one, man?
I mean, I can take an LED and put like blue paper over it, and it's blue. I mean, it's good enough, right?
Yeah, actually, you can't make blue out of red. That's part of the reason here.
That's a good point.
So the idea is that blue is on the short wavelength end of the spectrum, so that you can put a phosphor on top of it and down convert it to other colors. So you can make a blue LED into a white LED just by putting it in, encapsulating it in something with a white phosphor. So the flashlights you have, the headlights on a lot of cars these days that have white lights, those are all because of the blue LEDs. They're kind of buried inside, being turned into white. Red is a lower energy, so you can't up convert it to white. Blue, you can down convert.
We would like to ask the panelists to say something that they learned from today's conversation.
The national science, really important science place is paying you to make plastic pretty with gold.
Oh, I learned that it's okay to put chips in people as long as they're pretty.
Keep chloroform for just those spontaneous moments, you know? Just why not chloroform?
I have learned that if I'm ever suspecting a baseball player of being a robot, I'm gonna find you first, because I'm gonna have a lot of questions.